Assalamualaikum warahmatullahi wabarakatuh. Good afternoon,
Waalaikumsalam warahmatullahi
everyone.
wabarakatuh.
Welcome to quiz lecture of the Agriculture and Biosistem Engineering. This quiz lecture with the title of Role of Appropriate Technology for Supporting Agro-industrial Development. First of all, let me introduce myself. My name is Evita Nugroho, student from Agriculture and Biosistem Engineering, Gadjah Mada University, as the MC on today's event. This event is a part of a weekly series of workshops that are held twice a week to be a part of implementation of independent campus competition program with agriculture and biosystem engineering partner. Therefore, we will get to know more about agriculture technology and gaining various benefits. So don't miss out on participating in every series of this workshop. Before starting the series of event, let me explain the rule in Indonesian. Sebelum memulai rangkaian acara kuliah tamu ini, izinkan saya untuk menyampaikan beberapa tata tertib yang harus dipatuhi sepanjang kegiatan ini berlangsung. Yang pertama, peserta diwajibkan hadir 10 menit sebelum acara dimulai, yakni 12:50 waktu Indonesia bagian Barat. Yang kedua, peserta wajib menggunakan format penamaan instansi _ nama lengkap. Untuk mengubah format penamaan tersebut, Anda dapat menekan tombol di pojok kanan atas pada partisipan list, kemudian tekan More, lalu tekan Rename, dan isikan sesuai format yang diinginkan. Ketiga, peserta diharapkan menggunakan virtual background yang telah disediakan oleh panitia selama sesi workshop berlangsung. Virtual background tersebut dapat diakses melalui link yang akan disampaikan oleh panitia melalui kolom chat room Zoom atau pada link yang sudah dibagikan pada grup WhatsApp. Keempat, peserta diharapkan untuk mengaktifkan video selama sesi workshop berlangsung. Kelima, peserta wajib menonaktifkan suara selama sesi workshop berlangsung, kecuali memperoleh izin dari moderator atau panitia PKKM. Keenam, peserta yang mengalami kendala selama kegiatan berlangsung dapat menghubungi panitia melalui private chat. Ketujuh, peserta diharapkan berpakaian dan berperilaku sopan selama sesi workshop. Kedelapan, peserta dapat menyampaikan pertanyaan melalui kolom chat atau secara langsung melalui mikrofon setelah dipersilakan oleh moderator. Kesembilan, dimohon bagi para peserta untuk dapat mengisi presensi kehadiran melalui tautan yang akan disediakan ketika sesi berlangsung. Lalu terakhir, informasi seri selanjutnya workshop PKKM dapat dilihat pada akun Instagram kami, yakni @tpb.ugm, serta akun Facebook atau Twitter kami @tpbugm. Diharapkan seluruh peserta untuk mematuhi tata tertib yang ada supaya kuliah tamu dapat berjalan dengan lancar. For the first agenda, is an opening speech that will be delivered by Professor Dr. Ir Eni Harmayani, M.Sc, as the Dean of Faculty of Agriculture Teknologi Universitas Gadjah Mada. For Mrs. Mayan, this time is yours.
Thank you very much, Evita. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon,
Warahmatullahi wabarakatuh.
all. Honorable Professor Jik-Chang Leong, Dean of International College, National Pingtung University of Science and Technology, Taiwan. Dr. Andri Prima Nugroho, the moderator of this guest lecture, and all my beloved students of undergraduate program, Department of Agricultural Engineering and Biosystem. First of all, we are pleased to welcome Professor Leong to this class, even though I know that you have a busy schedule as a dean in NPUST, but you dedicate your time to this class. Thank you very much. And secondly, on behalf of Faculty of Agricultural Technology, UGM, I would like to thank Professor Leong for sharing knowledge and experience on this lecture titled Role of Appropriate Technology for supporting agro-industrial development. As you know, that Indonesia agro-industrial industry, maybe 90%, yeah, more 90% consists of small and medium enterprise, yeah, food and agriculture industry. So it is important, yeah, to improve the appropriate technology for the small and medium industry, so it can meet the international standards. Yeah. So I'm sure that during your long experience in Taiwan, I know Taiwan is very good in industrial approach, yeah, especially agriculture also. This lecture can benefit to all of us, especially for students. Yes. And I also pleased that although we are meet again through online meeting, but yes, we can continue our collaboration, I think, because yes, last time we met, we signed the MOU, yeah, in Taiwan, and we all have a same mission to improve our collaboration. Yes. So I hope in the next time we can create, yeah, more collaboration in terms of education, research, or public service. Yes. With both institutions involved. Yeah. Yes. So the objective of this lecture, I think the department put that the aim of this lectures is to establish good communication between the Bachelor of Agricultural Engineering program with partners, academics, stakeholders, and in the community to carry out the function of education to the community related to development of in the field that is focused on the agricultural engineering study program at this time. So yes, I think I know your CV and excellent experience. I hope we can gain from this lecture, especially students. And in the future, I hope we can send more students, yeah, to Taiwan.
Thank you.
Yeah, student agree with that? So I see happy face from the student. Yes. Yeah, I can send to your institution.
Yes, they are welcome.
Yeah, thank you very much. And I hope students also will gain chance to get insight and knowledge from your experience and enrich the knowledge from your research experience and also interdisciplinary approach in the application of mechanical engineering to this field. Yeah. Lastly, I would like to appreciate also the Department of Agricultural Engineering and Biosystem for conducting this guest lecture, and we hope we can get more benefit from this lecture, and I'm sure that we will have that. Thank you very much. Good afternoon. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Mrs. Maya, for the speech. Let's move on the next agenda. In this afternoon, we will discuss together with Professor Dr. Jik-Chang Leong, Dean of International College, National Pingtung University of Science and Technology. We will start this discussion with our moderator. He is Dr. Andri Prima Nugroho, STP M.Sc, that will be introduced by this curriculum vitae. His education background starts with undergraduate from Agriculture Engineering, Universitas Gadjah Mada, and then master and doctoral from School of Bioresource and Bioenvironmental Science on Kyushu University, Japan. His research interests in information technology in bioproduction engineering, precision agriculture, Agricultural Information System Cluster, International Commission of Agricultural Engineering. Without delaying time, let's start the discussion this afternoon with Mr. Andri.
Okay, thank you very much, Mbak Evita Nugroho as MC for today's lecture. Can you hear my voice clearly?
Yes.
Okay. Okay, first of all, I would like to thank you for all participants who joined in today's lecture. Let me start this agenda. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh.
Okay, honorable guest, Dean of Faculty of Agricultural Technology, Universitas Gadjah Mada, Prof. Harmayani for the speech for the opening of today's general lectures, and also our beloved students, lecture partner, and also our distinguished guest lecturer, Professor Jik-Chang Leong, as Dean of the International College Department of Vehicle Engineering, National Pingtung University of Science and Technology. I would like to say welcome in today's lectures, and let me remind you about this program at first. This one is one of the part of the PKKM program in the TPB UGM, and the main theme is the development of the healthy chocolate agriculture industry center, Cacao Bean to Bar, based on the smart technology to strengthen innovative learning and digital talented human resources. And then I believe that Prof. Leong, with his excellence research, is the part of the technology. And also the one keyword is matched in this topic is about the appropriate technology that I believe in Indonesia, in our society, is the technology is still expensive, we believe that. And the appropriate one is one of the keywords and terminology that maybe match with our condition right now. First of all, I would like to read Professor Leong's CV at first. This panitia, and yes, his name is Professor. The complete name is Professor Jik-Chang Leong, and the education background, he finished his BS, MS, and PhD from the University of Oklahoma, USA, in the same university, from the bachelor until PhD. And then his research interest in heat and mass transfer, flow visualization techniques, ventilation and fire safety in the long channel, car cabin air conditioning and ventilation system, magnetic fluid flow, and thermal fluid in smart agriculture. And yeah, from the CV we can see and spill out what is the expertise of the Prof. Leong here. Okay, let's start our lecture by giving time for Professor Leong for explaining his lectures. Okay, time is yours, Prof. Leong.
Okay, thank you, Dr. Arni, Andri, Dr. Andri. Before I get started, I would like to express my sincere thanks for inviting me, and it is a great honor for me to share my experience, especially the invitations by Dean Ernie. We started to collaborate a few years ago when Dean Ernie and some delegates came to Taiwan, and then we signed MOA together, and we would like, the two colleges would like to do more collaborations. So I think this is a very, very good chance for me as an engineer to introduce what we do as an engineer to help agriculture. Before I became the Dean for International College, I was solely doing research in engineering college. And at that time, I have no idea how agriculture works. So my idea was very simple. Oh, okay, we use engineering methods and we can do everything. But then a few years ago, I got this chance to come to International College, and that I worked together with some faculty members whose background is in agriculture. Then I start to realize things is not as easy as I thought as an engineer, because plants, they have different style, they have different forms. Animals, they have different behaviors. So this is something that we don't understand in engineers. For engineers, we do productions, manufacturing in the factory, and everything are the same. But in the farm, in the field, things are not the same. So from there, I learned we need to learn something from agriculture. We need to understand how agriculture works. And then as an engineers, we may be able to put ourselves into the same shoes and do something together. So once again, thank you, Dr. Ernie and Dr. Andri. And I hope in the future, in the near future, we do have chance to meet again in Taiwan. And then we will talk about how we can do collaborations in terms of educations, in terms of projects, how to promote the collaborations between the two universities and the colleges. So without wasting more time, I guess I'm going to switch to my PPT. And then if we have time, we can come back for more discussions.
Yes.
The topics of my presentation today is called Role of Appropriate Technology for Supporting Agricultural Industrial Development. So to me, this is a very, very big topic. Technology, there are tons and tons and tons of technologies out there, but which are the appropriate ones? So this technology can be a very high-class technology, and it can be a very low-class technology. So what kind of technologies do we need to promote? So that depends on our who we want to sell the ideas. If we are going to sell this technology to the farmers, first of all, the technology cannot be too expensive. The technology cannot be too difficult to manipulate or to carry out. If we are trying to sell this technology to the government, then this technology has to be advanced technology, because the government is trying to influence the whole country. So when I got these topics, I really think about it, and it seems to me to talk about this technology, I would like to use Beehive as an example to show you what I have been doing for the past few years and how engineering technology can be applied in agricultural area. So again, my name is J.C. Leong, and I'm the professor in the Department of Vehicle Engineering. In vehicle engineering, we deal with machines, we deal with electronics, we deal with maintenance, design, things like that. All right. Before I get started, I think we need to have a common ground. Therefore, I would like to introduce or explain how engineers do research. So if you look at the middle part, the approach, as an engineers, we mainly have three approaches. The first one is—
Prof.
Yes.
Leong, you didn't show your slideshow, so maybe can I check?
My sound?
No, slideshow for your PPT.
Oh, okay.
You forgot.
Sorry. Okay, so I would like to share.
Yes.
Okay, all right, thank you. Okay. Okay. Do you see it now?
Okay.
Oh,
yes.
Sorry. Okay. So before I get started, I think it is more appropriate for me to briefly introduce how engineers think and how they do research. So in the middle here is the approach. So as an engineers, we always tackle a problem from three different approaches. The first one is called analytical. So this approach mainly deal with equations, mathematics. So engineers would sit down, they understand the problem, and then they start to model. They use mathematical models to write equations. Once we construct the equations, then we try to solve the equations. When we solve the equations, then we know the answer. So from the answer, we can predict what are the significance of different parameters to the system or to the problem. If we want to improve or if we want to reduce some effects. So what are the key elements that we can play with? So this is called analytical. For example, most of us know F equals to MA. And when you solve the equations, then you know what what is the system going to respond. So this is analytical approach. And unfortunately, if we try to solve every problem through this approach, it is not possible, because sometimes the equations are too complicated. There is no way we can solve the equations. So there we have the second approach called computational. So if you look at the weather forecast, a lot of times the weather forecast will tell you, okay, tomorrow we are going to have wind blowing from the north, and the speed, the wind speed is so and so, and then the temperature is how cold or how hot. So how do we predict? How do we forecast the weather? Actually, as an engineers, we use computer. We write programs, and then we use program to solve the equation, solve these systems. Then from there, we get some numbers, and then from the numbers, we can tell what may happen in the future. So this is computational. And the last one, and the most frequently used approach, is called experimental. So experimental in general, we have two kinds. One is called the lab work. So when you have the equipment, you stay in the lab, and then you can do all the measurements, and then you do recording. But sometimes lab work is too ideal, because if you go to the field works, many things can affect the situations. For example, the weather, the pets, the soil, the water. So a lot of times, once you have some background on lab work, you need to go to do field work. You have to go to the farm and do your real measurement. And from there, you collect the data, you go back to your lab, and then you remodel your experiment. So these are how engineers do things. So with this, I would like to use beekeeping as an example. How we look at beekeeping's problem through analytical, through computational, and experimental. So for my slide that is going to follow, the first part, I will talk about how we use computational approach to understand beekeeping. And from there, I would go to my second part, and how we redesign the beehive and in the lab. And finally, I would briefly talk about analytical ways that is used for beekeeping. So in this case, we actually use some experimental data, and then we build mathematical model. And then from the mathematical models, these equations may be able to help us in redesign our equipment. All right. So why do I want to do beekeeping? So if you look at these slides, we see that the temperature in Taiwan is actually increasing tremendously. And global warming is a big issue. Everyone talk about it because global warming is dangerous. It is no good for human sustainability. So we are not talking about the whole world. Just look at Taiwan itself. The first line is the centennial trend. And you can see the slope of the line is not tremendous. If you look at the 50 years trend, well, the slope gets steeper. And if you look at the 10 years trend, it is even steeper. So which means actually the temperature is increasing more and more faster. So this is a terrible problem for everyone, especially for the beekeepers. Because when the temperature increases, they change their behavior. In the past, maybe the beekeeper, when they raise the bee, they have a certain technique. But in the recent years, they have to change because the temperature is changing. So for those of us who are not too understand what is happening with bees, in general, the bees, they tend to stay in their beehive, especially when the temperature is less than 35 degrees Celsius. If the beehive get too hot, then the bees are not comfortable. So when they're not comfortable, they have to do extra work to cool down the beehive. So as you can think, for example, if the bees, they have more time to collect honey, they can go out to work and collect honey and pollen and come back to the beehive. So the production of honey from the beehive is higher. But now let's say if the beehive temperature is too high, so the bee has to spend a lot of effort. They have to wing their wings so that the temperature of the beehives can come down. So if they do not go out to collect honey, then as a matter of fact, the production for honey decreases, and this is harmful for the beekeeper. So that is why we want to look at this problem. We want to understand how, as a human beings, we can help the bees cool down, and at the same time, we can improve the temperature and improve the honey productions. Okay. So first of all, I will talk about the first part, computational approach, how we use computer simulations through virtual modeling and simulations. We look at how the beehive behave if we do different things to the beehive. So the objective of this work was we use an approach called fluid dynamics, computational fluid dynamics, CFD, which means we use computer, we build a virtual model, and then we set up some limitations, we set up the right equations and boundary conditions. And then we ask the computer to do simulations. The computer may run for several hours, up to several days. And from there, we collect the information, we collect the data. With this data, we were able to visualize what is happening inside a beehive. Because visualizations of a beehive is almost impossible, because you would not want to affect the bees. And if you do not affect the bees, you cannot visualize what happens in the beehive. So that is a dilemma. So one way to do this is we use a computer. So in this work, we try to modify different factors. For example, the fan locations. If we want to cool down a beehive, where should we put the fan? And if we put the fan, what kind of direction? Should we blow the air into the beehive, or should we remove the hot air from the beehive? What are the influence? And then we change, we test, we examine different fan type. For example, we have the cross flow fans and the axial flow fans. I will talk about this in later slides. And also what happens to the top cover, okay? So in the beginnings, I don't understand beekeeping technology. So at first I thought, wow, this is a very simple problem. We can easily solve it. But then when me and my students come together and we try to understand the beehive, we found that in Taiwan or in the northern part of Asia, actually, this is called brood. Brood is the young bee. Like for example, the pupa, the eggs, those are called brood. So actually in the beehive, the number of broods, it changes throughout the whole year. For example, in the cold weather, in January, you do not have eggs and pupa in a beehive. And then from February onwards, the numbers of broods actually increases until June. And then from there, the number of broods actually is decreasing until winter times. You have no more eggs. So that is what happening. So actually, the numbers of bees and brood in a beehive, it changes in different months. So for this case, when we know this problem, then we try to remodel, we try to draw the beehive in the bee box. So in this case, this is the box where the beekeeper keep the bees. And in the bee box, we have the beehive. So this is the places where you have the pupa and the eggs and mainly the bees. And from this table, we can see that we have to calculate the number of broods, the number of bees, and then we calculate the number of cells occupied by broods and pollens, and also the honey and all these things. From there, we have to build the virtual model for a honeybee hive. And then from there, we have to use some concepts from heat transfer and fluid mechanics. In engineering terms, we call this effective parameter. So first of all, we have to use porosity, because in the beehive, it consists of mainly of the solid phase, which is the bee, and also the frame and the bee wax, and then also the air. So the first things we need to do is we have to construct a porosity model where we can differentiate air and non-air within the beehive. And then from there, we have to construct the effective properties that needs to be used for this problem, especially, for example, the density, and then the heat capacity, and also the thermal conductivity. So these are the properties. And then we also think about the heat generations, because in a beehive, you have the adult bees and you have the broods. And each of these adult bees and broods, they actually create heats, just like human beings. When we stay in a room, after eating, we produce heat. And this heat is the heat source for the beehive. So these are the main numbers we have to do calculations before we can do simulations. And then from there, we have to calculate the effective parameters for the brood, beehive, bee wax, honey, pollen. And for example, in this case, I will pick January, April, July, and September. So these 4 months for examples for the study. So these are the sizes and the shape for the beehive in the bee box. So again, for the brood, because the brood is very small, so each of these brood, it actually produce 1.12 milliwatts of energy. And then for the bee itself, depending on different months, we have to calculate the heat generations per bee. So based on these numbers, we have construct a complete simplified models for the beehive. So before I go any further, I would like to briefly introduce in the bee hive, we have the honeycomb. The honeycomb is these things. This is the frame, and in the frame we have the honey cell, where you have the pupa and also the egg. And in between the frame, we have the bee space. This is the space where the bees move around in the beehive. Okay, so from here we were able to calculate different parameters. And okay, so once we have everything set up, the first thing we need to do is we use computer software, and then we put the numbers in, and we were able to calculate. For example, in this case, if we look at the beehive from the side view, so this is the entrance where the bees come in and go into the bee box, and then the bees would come out from this small entrance. So if we look at this bee box from the side view, actually we see natural convections. If bees generate heat in the bee box, we can see that actually the temperature in the beehive is very high. It can go up to about 39 degrees Celsius. So this is no good for the beehive. So when this happened in July, especially in summertime, the air is very hot. So the whole box is very hot. So the bees have to do a lot of efforts to cool down the system. So that is why if you collect bees honey from July, the production is not that high. So unless we do some things from human side. So if we look at visualize the bee box from top view, if we cut the bee box into half, we see that the center part of the bee hive is very, very high in temperature. So this is the problem for a beehive. If we look from the front side, which means we look from this side, again, we can see the top portions is the bee space, because these are mainly air, and these are the bee wax. So the temperature is higher in these portions, okay? So from here, through engineering means, we understand what happens if we do not help the bees to cool down. The temperature where it can be as high as 39.85 degrees Celsius. All right. So the next thing we call forced convection. So which means now if I install fan and I blow in cold air into the beehive, what would happen? Okay. So for those who know CFD, we have to change our boundary conditions, the settings. And in this figure, again, look at how we can visualize the flow. If you look at this line, it means the cold air enter the bee box from this gap. When it blow inside, and then some of the air would rotate. It would go into the bee space, do some rotations, and then some would come out from the main entrance. Oh, so this is something that we do not expect in the beginning. But now we see, all right, if we put fans into the beehive, some air would come out from here. But the big problem is that a lot of air would come out from the side. You see, from the side. Okay, all right. So now the next thing is that we consider two different kind of fan. One is called the cross flow fan, this kind of fan. The other one is the axial fan. This is the fan, if you are familiar with computer science, you always see this kind of fan. So these two fans, they all do the same functions, but they come in different prices. This is $15 US, very cheap. But this thing is 3 times the price. So as an engineers, if we want to promote or if we want to tell the farmers, oh, come, buy my system. So you don't ask them to pay extra money. You would always think, well, they want to save money. So in the future, we want to help them to install this kind of fan, but not this kind of fan, okay? All right, so now we know if we do not install fan, the temperature in the beehive is very high. And this is going to be harmful to honey productions. Now we know if we want to put fans, this can improve the ventilations. It can reduce the temperature in the beehive. And again, we want to choose the good fans, the affordable fan for our farmers. So now we want to use this fan. And the size for these fans, if you go to the shop, a small fan is about 4 centimeter in height and in width. So now we are going to simulate. I'm going to put a fan over here, which is over here, and see what happens to my beehive. Okay, now, do you still remember? If we put the cross flow fan, you can see when air blows into the beehive from the side, wow, this is the low temperature. The temperature is about 29 degrees Celsius, okay? And the high temperature is in the middle. Now it's come here, and it is about 38 degrees Celsius in the middle. So this is cooler. Still remember last time it was like about 39 point something. Now, if I use the axial fan flow, if I introduce the fan in over here, because the fan is thicker, now we have a bigger gap. And again, we can see the temperature is over here. The high temperature is about 38.1. And if you look at this part, you can see there is some rotations. Actually, the flow is like rotating on top of the B frame and in the gap. Okay, so it seems to us if we use fan, we are able to reduce the temperature in the beehive. So good things. Okay, but is this the only way? Now we blow in the air. What happens if we flip the fan? We remove the hot air. Okay, let's see. All right, now with the same fan, this is cross flow fan. This is the axial flow fan. Do you remember? If we change the directions, if we remove the air from the beehive, look at the temperature, 37. Okay, in the previous one, 38. If we blow in. Now, if we remove air, 37. Okay, and look at the high temperature region. It reduces in size, it becomes smaller. So this is a very, very good tool. As an engineer, we do not have to go to the farm, or we do not have to disturb the bees colony. All we need to do is we use computer, we do the virtual modeling, and then we can test what happens. So just by very simple techniques, we come up with good conclusions. If in the future, if I go to the beekeeper, I can tell him, okay, Mr. So-and-so, I'm going to tell you, you can reduce the temperature of your beehive if you use the fan. So what kind of fan do you use? Okay, if possible, I would recommend you use axial flow fan, okay? And then maybe the farmer will ask you, well, so how do I blow my air? Should I blow my air into the beehive, or should I remove it? Then from my study, I can tell him, okay, you have to remove the hot air from your beehive because this is going to give you the best result. So just through engineering approach, okay? All right, and then now I will come to some short remarks. So from this study, we found that air extraction mode is the best way to cool down the beehive. And because of the time, I did not put my slide. And actually, if you use fan to cool down your beehive, it is better to improve the tightness of the top cover because you don't want air to leak from your beehive. And then we also calculate the COP value from engineering's understanding. So COP is a ratio, is a value that signifies the amount of heat removal per unit power consumed. So if we look at this plot, so this guy, the green one is the natural convections. You can see if you let the bee remove the heat by themselves, this is the amount they can remove. If we use fan to remove, you see the improvements, okay? Even though we use different fan, the amount of heat removed is different. But if we compare the COP value, because when you run the fan, you have to pay electricity. Every month, you are paying the electricity bill. So the cost for the beekeepers are very, very important. So if we look at this COP value, we can tell, okay, if you use the cross one, the COP is 7.92. And if you use, sorry, I think this is not a lie. If you use the cross one, is the blue one, is 1.54. And if you use the axial one, the red one, this is 7.92. So which means if you use the axial fan, you are actually save more money in comparison to the cross flow fan, okay? So this is something that we can tell to the farmers just by using computer simulations. All right, the next thing is I would like to talk about experimental approach. So I may need to speed up a little bit. Okay, so actually this is not a new idea. In Europe, in UK, actually they are scientists. They build electronics combined with the beehive. So they would be able to monitor what is happening in the beehive. Okay, so very similar. We do the same things in my lab. So this is my hardware structure. So in the bee box, so we are going to build a control units. In the control units, we use Arduino board, and then we have the LCD display, and the Arduino board is connected to a weight sensor, CO2 sensor, and the humidity and temperature sensor. So these sensors are used to monitor, to keep track of what is happening in the beehive, because somehow you do not want to open this lid because this is going to disturb the bees, and that is no good. So we can always put the sensor to the box and do the monitoring. So once these sensors collect the data, it will send the data back to our Arduino board. And in this Arduino board, I have the Wi-Fi module. And the Wi-Fi module would send the data to cloud platforms. And through the cloud platforms, the observer, they can download or they can visualize what is happening, keep track, what is happening in the B box. And for the administrator, again, they can, through the cloud platforms, they can use portable device and send commands back to my Arduino board. And my Arduino board will send information to the relay, and relay would activate the fan. So by that, the fan can increase the ventilation for my B box. So this is our design strategy. So that is the hardware. So what happens to the software? So the first thing, my students need to learn Arduino software. So they need to know how to program the Arduino programming. And then they need to know how to use the ThinkSpeak. This is the cloud, the ones that I talk about, the cloud. For those of you who would like to do this kind of project, you can apply a free account in ThinkSpeak, and then you can use their channel up to 3 projects for free. You don't have to pay anything. Okay, so from Arduino software, we can talk, communicate with ThinkSpeak and send information. Okay, and then from the ThinkSpeak, you can trace what is happening in the B box. And then if my observer, they wants to control the B box using their cell phone, so we have to write a program in MIT App Inventor. So this is a module programming. So you just put different things together and you compile it, and then you can create this kind of software. Okay. So this is the interface that my student constructed. So you can input the IP address, and then you can turn on or off the fan for the beehive. You can see the temperature and the humidity of readings, CO2 readings, and also how heavy is the bee box. So this is the wiring for the whole project. Okay. So from the observer, so the first thing he need to do is he need to connect to the Wi-Fi, and then this is the LCD screen monitor. Then by doing different weighting, then the numbers would change. For example, in this case, the screen is actually showing T equals to 28 degrees Celsius. The humidity is 65%, and then the weight for the bottle is 500 and something gram, and then the CO2 is 700 something ppm. So these are the plots you can see from ThinkSpeak. Okay, so this is what happens for the observer, but somehow the observer cannot control the fan. Okay, now again, for the manager, for example, the beekeeper, he may have workers to help him to manage anything happens to the bee box. So this is the situations. Now, when he key in the IP address, he will connect to the Arduino board, and from there he can do the readings, and he can even turn on or turn off the fan. And in this case, we use LED for simplifications. Okay. All right. So with this, let's see what is good about this device. So this device can measure and displays temperature, humidity, weight, and CO2 concentrations. So for the temperature, it would be from 0 to 50. Still remember, I was talking about a suitable temperature for a beehive is about 15 degrees Celsius up to 38 degrees Celsius. That is the minimum and maximum. If the temperature in the beehive is too much, the bees will fly away. They won't stay in the beehive. So we do not need a big range. So 0 to 50 is good enough for our case. And the humidity is 20 to 95, CO2, and the weight up to 10 kilogram per sensor. All right. So in the lab, once we come up with this device, we have to do experiment. So we have to know how good this device is. So we have to do the relative error. Okay. So for my temperature and humidity, the relative error is about 2 degrees Celsius and 5% humidity, relative humidity. And the relative error for weight is less than 3%. So 3%, I think, is good enough for beekeepers, because when they know that the beehive is getting more and more heavier, right away they know, okay, maybe it is time for me to open up the lid and collect my honey, okay? And in my lab, because we do not have benchmark measurements for CO2 concentrations, so up to right now, we are unable to determine what is the relative error for my CO2 concentrations. And look at the price. This unit is only 75 USD, very, very cheap, very cheap. And not to mention, about half of this price comes from the CO2 sensor. So for the beekeepers, if they do not want to use CO2, let's say they think, oh, this is too expensive, and CO2 is not important for my beekeeping's daily work. Okay, they just remove CO2 sensor. If they remove the CO2 sensor, you can cut down the price by half, about just 30 US dollar. Very, very affordable for beekeepers. So that is why, as a university community or a researcher, we always think about how we can cut down the cost. And this kind of cost is affordable for the farmers. Okay, so let's say if you want to do some high-tech device, so in the future, you can put GPS positioning. You can do beehive heating if you are in the cold country, okay? And then you can also have active detection for abnormal data. For example, if a beehive is attacked by other insects, so maybe the bees are fleeing, they are flying away, or the number of bees are decreasing. So with this kind of device, the beekeepers, they know something is happening, something bad is happening to the beehive, then they can have immediate reactions to save their beehive, okay? So these are the future functions if you want to do more. And this kind of technology you can use for greenhouse, you can use for kitchens, and you can even use this for detections for other dangerous gases in different working space, okay? So this is how we can extend the use of these systems. All right, finally, I would like to briefly talk about analytical approach, how we can use mathematics to tie with this kind of projects, okay? So in this case, I want to refine my weighting technology. Like in the previous slide, I talked about we use weight sensor, and I think weight sensor is not good enough. Can we do some modeling? So again, we use different accelerometers and combine with weighting sensors, okay? So first of all, we look at the engineering textbook, and then we know, okay, for any things that rotate, it has yaw angle, roll angle, and pitch angle. So first of all, we have to do some basic experiment to make sure our sensors give us the right data. Why do I care about these angles? Because if we put a beehive, normally you just put on the ground, and sometimes the ground is not level, it is slope. So therefore, it is maybe important for us to know the slope that is associated to the beehive, okay? So in the lab, we do experiment. We put 4 scale, and we try to measure if the beehive is not placed horizontal, it's like tilted. This side is lower, this side is higher. Then what is going to happen to my readings? Okay, so these are the readings. When I pitch my angles, 0 means they are flat. Okay, if minus means this part is going up. If the pitch angle is positive, which means this part is going down, you can see the reading for 4 scale, it varies a lot. So this is no good for measurement, okay? Especially in the lab, we have a very bad data. So what would happen if we put these things in the farm? It is not going to give us meaningful data. So we have to fix this problem before we can introduce this technology to the farmers, okay? So we do some data improvement. So we put some spring systems to the scale. Look at this, okay? So by doing this improvement, we were able to improve the data. Look at this data. It becomes across very beautiful data. And this one, it improved to these sections, okay, across. And from this data, we were able to do some calculations, mathematical modeling, and then we get some numbers, okay? And from these numbers, we can use Taylor series expansions from the simple mathematics. Then we come up with the mass of the beehive at different pitch angle and row angle. It can be predicted. It can be predicted, okay? So if you look at this part, this graph, A, B, C, D, these are the lab data. And A, B, C, D, these are the numbers I calculate from my equations. And look at them, they are very, very good in agreement, okay? So this gives me a very good confidence how we can use this number to remodel or improve my Arduino programming. And these parts come from an analytical approach, okay? So before I stop, I would like to come back to my appropriate engineering technology for supporting agro-industrial development. So if you still remember, for engineering technology, we have experiment. We can use a computer to do simulations. And if possible, if you want to improve the precisions of the model, you may need to use analytical means. So by combining these 3 different approaches, we as an engineers can help agro-industrial development. Before we really, the 2 teams merge and come together for research, we need to understand, why do we want to do things together? Engineers do engineers things. Agriculturalists, they do their own agri-farming. So why do we want to ask them to come together? Well, there are several benefits. First of all, the problem becomes very, very interesting. For example, in this case, if I have never get started with this beehive problem, I think this is a very, very simple problem. But as I spend time to really think about it, this is very interesting. And this is also very inspiring. Now, let's say I am able to come up with a device that measures the temperature, the climate data in a beehive. And I can use this for other places. I can do this for the greenhouse. I can do this for the kitchen. So these kind of projects are very, very inspiring. Now you broaden the applications of your engineering techniques. And not to mention, this is interdisciplinary. And by doing these projects, by learning, you actually gain more and more knowledge. You tend to understand how different disciplines work, okay? And with these benefits, and a lot of times they have immediate applications. For example, if the farmers, if I can further reduce the cost for my device, and I can go approach the beekeepers and maybe I would set up 1 or 2 prototypes and let them test it and see if my prototype is workable, is durable, and how I can improve the applications. And for the research teams, and a lot of times these kind of projects, they can lead to patents and they can lead to technology transfer. Because when you sell these ideas, sell these products to the manufacturers, they have more access. They can build more, and then they can sell to the whole country, to the whole Asia, or even the whole world. And not to mention, for researchers, for the student and teachers, you can do publications because this is interdisciplinary study. And nowadays, many journals, they encourage interdisciplinary study. Okay? All right, these are the good things. So how about the bad things? More challenging. 2 or 3 years ago, when I start this project in my lab, I asked my student, well, let's sit together and we go look for some information. And then my student came back to me and they say, we cannot find any data. For example, if you want to know how the bees, the number of bees varies in the month, there's no data, very scarce. Why? Because this is mainly for the farmers, for the beekeepers. The researchers, they don't put this data in the internet. They don't publish this kind of data in the journal. So it is very challenging. So, for researcher, you do not back off. You just keep going. And then most likely when you tackle the problems, then you will get some result. And the mutual understanding is very important because, for example, I always think with engineering mindset, but when you approach the beekeepers, when you approach the faculty members from the College of Agriculture, they have different thinking. They will say, no, Dr. Leong, it is not supposed to work this way. Okay, what you think is too simple. The real world is blah, 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 blah. So your thinking is wrong. You have to modify, you have to change. So if you do not talk to them, you would never understand the real situations. Then you solve the wrong problem, okay? So, and then trust is very important. Sometimes if you do not gain the trust from the other party, they try not to tell you everything, okay? When you do not get the trust, you don't get the right information, then you are stuck. You cannot move on, okay? So trust amongst the teammates are very important. And real life experience is something that I emphasize a lot. When we do the research, I actually ask some of my students to go to do beekeeping's work. I send them to the bee farm, and then they have to wear the net, wear the glove, and then try to do the bee honey collections. So from there, they get the experience. Oh, they know, okay, what is the bee space? How is the bee behave? What is the pollen? What is the honey cell? So those are the things that they have to gain. As an engineers, we are not supposed to sit in the lab and think, but you have to go out to feel. And then from there, you can do interdisciplinary study. And data collection is very important because different people, they are from different background. They have different way of collecting data, different behavior, different traditions. And sometimes the data they collect may not be useful for engineers. And sometimes the information we collect are not useful for the farmers. So sometimes we have to be very cautious about how we collect the data. And for physical interpretations, for example, in my previous slide, when we do the visualizations of the beehive, we see some plots, some contours. Some spots are very hot, some spots are very cold. So we have to think about the real situations and try to make some sense out of it. Okay, so before I stop my presentations again, I would like to encourage our students and faculty members in the future, if you want to get involved in interdisciplinary projects, the first thing you need to be ready is the patience. Always be patient. Sometimes you can rush, sometimes you cannot, because this is, it takes time to develop the trust. It takes time to communicate with the different teams with different backgrounds. And then a lot of times, what you know, your past experience, your past knowledge may not be applicable in this case. So when this happens, you need to be creative. You need to come up with innovations, how you solve the real problems based on your simplified engineering mindset. So innovation, again, is another thing that can break through the barrier. And the last is communications. Before you get started, talk. When you don't understand, you talk. When you have doubt, you talk. When you come up with a good idea, you talk. Because you think this idea is good, but it may be a trash idea for your team members. So talk and talk and talk. Okay, so with this, I would like to conclude my presentations. Again, thanks everyone, especially Dean, Arnie, and also Dr. Andri, for inviting me and giving me this precious chance to share my experience. And I think I will give Dr. Andri.
Okay, thank you very much, Prof. Leong, for your interesting presentation. And I would like to, we also have such kind of research in our department. We have smart agriculture research. So we also use appropriate technology, especially low-cost system. We introduce low-cost system, and we're thinking about how to make the appropriate technology can work to our farmer.
Yes.
Especially we imitate the existing by using the low-cost one.
Yes.
Okay, before I would like to invite all the participant, if you have any discussion or something to ask, please kindly write down in the comment section, or you can raise your hand and you can open your mic. If you have anyone to asking directly to Prof. Leong, please raise your hand and we will give you a chance. Okay, the first question is come from Mr. Daniel Saputra from Unsri. What kind of camera were you used to take the pictures on the heat inside the beehive? Or are you using the thermistor and drawn the picture based on the record on the thermistor? This is a question from Mr. Daniel.
Okay, thank you. It is very difficult to take picture in the beehive because first of all, the beehive is made of wood. So in some lab work, they actually use plexiglass to build the beehive. And still, when the bees is moving around, it is very difficult for you to understand how the temperature varies within the beehive. So there is no way. There is no way. So what we do is that we use computer simulations. You just do calculations. And then from there, from our simulations result, we can look at different sections from top to the bottom, from left to the right, from front to the back, anywhere. As long as you get the results, then you can see. So once we see where is the hot locations in the beehive, then in the future, we can always put sensor into that area to justify our result. So it is almost impossible to use visual technology to see what happens in the beehive. But somehow, they are researchers, they are actually using ultrasonic sensors to sense, to understand what happens to the beehive. But again, this technique is very, very expensive. Yes.
And how about the thermal camera? Have you ever used the thermal camera?
We use thermal camera but only for surface. And we are unable to see through, to penetrate the solid phase. So let's say if you use a plexiglass for the beehive, you can only see the temperature distributions of the surface of the beehive, but not inside. Yeah, so that is one of the big trouble.
Yeah.
Yes.
Mr. Daniel, is it answer your question? Hopefully you can understand the answer.
So
Okay.
that means you put a lot of temperature sensor on the beehive?
Okay. Not yet. Currently, we use the temperature and humidity sensor. Our strategy would be we suck out some air from the beehive, and then we can do analysis. Because in the beginning, I know not much about beehive. We thought we are going to put the sensor into the beehive, but after talking to some beekeepers, they say, wow, this may not be a good idea, because for the bees, when they see some alien material in the beehive, they would attack the sensor. They would attack the sensors, and maybe they would put some wax that cover the sensors. So most likely, maybe the sensor worked for a few days, and then you have to change a new one. So we have not tried this yet, but most likely we are not going to put the sensor into the beehive. But still, we can put the needle type or the thermocouple type. That may be more flexible, more practical.
Oh, thermocouple, okay.
Yeah, thermocouple is more.
Hair, the one that is very small one.
Yes, very small one. And then we try to hide it somewhere so that the bees don't see it. Because
invisible.
The temperature and humidity sensor is very big. It's bigger than the bees. So they will see, oh, okay, we want to attack them.
Okay. Thank you very much.
Thank you, Professor.
Yeah, Mr. Daniel, actually the result of the heat map, actually the simulation.
Yes, it's a simulation.
For measurement, but it is simulation process.
Okay, thank you.
Thank you.
Okay, I would like to invite maybe Dr. Chandra. Can you hear my voice? And you can ask directly to Prof. Leong here. Dr. Chandra now is in Austria.
He's in Austria.
Actually, he supervised maybe two students.
Wow.
Two student exchange. Now he is in Austria.
Wow. Good for him.
Hello, Dr. Chandra, please.
Good morning, Dr. Andri and Professor Leong.
Hi, Dr. Chandra.
Nice to meet you again. Talk in virtually.
Yes.
Hopefully, soonly we can meet directly each other. Maybe we visit to NPUST or you visit to Indonesia.
Yes.
And this topic actually also close to the expertise of Dr. Andri, as he mentioned that in our department also we do almost the same way about the appropriate technology, and
yes,
I think we also can learn a lot of new things about the application of new this technology to help our farmer, especially for developing country like Indonesia, because the cost is very important. If too expensive, it's so hard to our farmer to adapt the technology, and what you introduce to us is very important to us. And okay, actually I have written in the chat room about my question, but okay, because Dr. Andri already give me chance to open it. So I will repeat the question. Regarding the development of low-cost system, is there any standard or regulation for developing both hardware and software, especially to make sure the accuracy and the precision? Is there any?
Okay, I think there is no strict standard for devices or equipments to be used in the farm. But for me, I think two main requirements. The first one is the cost. It must be as low as possible. If it is free, even best, but not a small cost. And the second thing is the durations. We have to test and make sure the equipment is working for a long time. Then we can promote to the farmers, because as you know, the farmers, they are less trained, so that sometimes they would use the equipment wrongly. And sometimes once they spend some time to buy the equipment, and then the equipment cannot be used after 1 year. So then the farmers, they lost their confidence on the university, and they thought, well, I don't want to buy anything and any listens to the professors, because those things don't work. So I think for us, it is very important for an educator. We look for the best solutions in terms of cost, and then we need to go to the farm and test our prototype for free to the farmers, so that once they use it, and then they have confidence for once, and then for us, we know how good or how bad our equipment is, how to improve. For example, we need to make our things waterproof, and maybe how to do the settings of the equipment as easy as possible for the farmers. So that would improve the farmers' willingness to use our equipment. Yeah, I think those are the not the straight standard, but I think for educator and researcher, we need to have this in mind. Yes.
Thank you. And one more. I'm interested when you say that as a researcher, we must go to field, not just stay in the laboratory.
Yeah.
Yes.
So,
totally agree.
So, do you go to the field every time, or how you know the problem face the farmer?
Okay.
Because it's very, very important to us for developing a technology to help their problems.
Yes.
Can you share to us your experience?
Yes. So for me, I don't have too much time to go to the farm, but I always have invite young professors, young faculty members, because they have more time, and then some on frequent durations we would call for meeting and ask them, oh, okay, so what is happening and what is the problem? Then we talk about it, and of course. When I have times, I would go to the farm to talk to the farmers. So last year, when not this year but last year, when the beekeepers they collect the honeybee, the honey. So I and my students went there. We spent 1 day over there and see how the beekeepers actually work. And like, for example, they would move the box to different places, where they place it, what are the steps, the SOP, they do the honey collections. So those are the things that we have to understand before we can come up with a good solutions or good equipment for the user. Yes. And this year, I also talked to another farmers. He owned an avocado farm. But he has just a few boxes. He is not really a beekeeper, but he wants to do something. So last time I talked to him and say I want to go to his farm and see, not as a professional beekeepers, how they keep their bees. Because for the professional keepers, they have 200 box or 300 box of bees. But for this gentleman, he has, I think, less than 5 boxes. But he thinks the bees, the reason he wants to keep the bees is because the bees help him pollinations for his fruit tree. So that's why he has bee in his farm. So I think maybe this is a good way for me to test my equipment, because less field, less bee box, and yeah, I think that is another approach. Yes.
Thank you very much.
Okay, one more.
Yes.
Maybe we continue the question from Dr. Chandra regarding the support. We support the farmer by using the free system or free system, and the question is how long it will be the support. Now, this is also one of the important to know that. In your case, yes.
I think yes. I think for us to work together with the farmers, like I said before, I think I'm not going to for the professional beekeepers because a lot of times they are money oriented. They don't want to try anything because anything goes wrong that would hurt their income. So instead of going to the professional beekeepers, I most likely will approach the other gentlemen who have 5 box. So in my case, I would build the devices from my own fundings. And then I would approach him and say, you don't have to do anything. You just let me install my equipment in your bee box. And then we can do the data collections. And then we can share the information. And for him, he just tell us what is good, what is bad about our equipment. Then that is all I need from him. So we can do this maybe as long as we have enough funding. And not to mention, if we build these equipments by ourselves, it is cheap. So that is not a big burden for our research. Yeah, and then for the farmers, he has nothing to lose. So I think this is a win-win situations for all of us. Yeah.
Yeah, that I can catch from your statement is we have to have a friends of the farmer.
Yes.
Yeah,
yes,
I think that's
yes.
the important things.
Yes, yes. And sometimes if you don't earn their trust, they would say no for every request you make. So you have to make friends with them first and then go visit them 1 time, 2 times, 3 times, have tea, have coffee together. Then you make proposal.
Yeah.
It takes time.
It's like a social approach.
Yes, correct.
Okay, Dr. Chandra, you have any other question?
Enough. Thank you very much, Professor.
Okay,
Leong,
thank you, Dr. Chandra. Okay, we move to the next question. Is come from Mr. Rifdan Firmansyah. Can you hear my voice? And you can open mic and
Yes,
asking
Pak Andri.
directly. Okay,
Yes.
please.
Thank you very much, Professor Leong. Nice to meet
Thank you.
again.
Nice to meet
I am
you.
one of the NPUST alumni too with Pak Chandra.
Oh, okay.
This is a reunion.
Yes.
Yes.
Okay, right now I'm working in the Bapanas, just like from the Directorate of Environment. Yeah.
Yes.
Right now, I had one project related to the adaptation of the new technology for the farmers. Maybe for the first question has been answered by Mr. Chandra's questions by you. Maybe related to right now we just develop the system dynamics. Yeah, system dynamics related to the system, and then I saw your presentation was very good, and maybe I just want to know about how you can measure the indicator, like from the sensor. You made the local system, right?
Yes.
That will be robust and more accurate, because you know the situation at the agriculture and the industrial are precisely different, right?
Yes.
And then the second, did you build the early warning system? I mean, if the fan is turned off and then the indicator will give some signal to the mobile phone or any other devices that you engage with the system. Maybe that's the questions. Thank you.
Okay. All right. Thank you. It is good to see you again. Yeah. I think the robustness is a very important issue for the systems. Because currently I still looking for the beekeepers to work together. So I think in the future we can make the system more robust. In terms of precisions, currently we do in the lab we do experiment. For example, I heat up the bee box at certain degree, and then I use thermocouples to measure the temperature and see how precise our system can predict or can measure the temperature. And the same thing happens to the humidity sensor. We unfortunately we are unable to buy the CO2 high-tech equipment yet. So that's why we do not have a very good confidence on how precise our equipment can measure the CO2. So I think double checking the numbers, the values is something that we can do in the lab. I think for the beekeepers, they don't require a high precision data. But more important is that the data itself can give them some meanings. For example, the temperature is increasing, then they need to do the right actions. Or let's say the weight of the bee box is decreasing, then they know the populations of the bee is fleeting away. So they may need to go to the farm to stop the fleeting of the bee colony. So I think those are the trend is more important in this sense. Of course, for engineers, we always go for higher precision and higher precisions. And do remember, when we go for high precisions, we are talking about higher costs. And the higher cost is something that hurts our promotions of technology to the farmers. So there should be a balance point between acceptable level for the farmers with appropriate price. And then last time I actually did talk to a professor from the university, and if possible, we can come up with the AI systems. But unfortunately, trust has not been built yet. So we need more communications so we can do the AI part of it. And talking about the alert systems, I think this is a very easy thing. Frankly speaking, we have not tried it, but someone in the university, they do have this successful experience. Let's say if the sensing systems, they found something abnormal, instead of sending the information to the app, they would send an SMS message to the manager. So right away, even though the manager, they turn off the apps, still they get the message. Then they can respond to the system right away. So I think sending out the alert through the app may not be the best idea, but sending the SMS is a better idea. Yes. Thank you.
Thank you very much for your
Thank you.
Answers, Professor.
Thank you.
Yeah.
Okay, enough, Mr. Rifdan. Okay. Yeah, I can like some insight from your explanation regarding the some technology, actually some idea regarding artificial intelligence and also time series analysis can be adapted to for the processing. I think the processing, and then the way sometimes the complex system they use control, and then for the appropriate maybe like a recommendation for the farmer maybe is also one of the key technology that might like a decision support, I think.
Yes. But I think that is the maybe the second or the third step of the project, because the first one is that we have to come up with the prototype, and then we have to make sure the user they like the system, they accept the system. Then from there we can move on to the AI. Otherwise, we have no direct way of collecting the information. We have no user who have confidence on the system. Then it is very difficult to push on the whole project.
It's like a milestone. We have milestones step by step.
Yes.
Yeah. Okay. Okay, we move to the next question. Is come from Mr. Guyup Mardian. Can you open mic? Check.
Hello.
Yes. Okay. Okay, Mr. Guyup, please. He is a doctoral student in our department. Yeah.
Okay, good.
Yeah. Okay, please, Mr. Guyup.
Yes. Okay, good afternoon, Prof. Leong.
Good afternoon.
Nice to meet you.
Nice to meet you.
Okay, I would like to ask about your technology. And your technology does the require special abilities for run the local system for the farmer?
No, I think the technology come into two levels. For example, for the user, for those who are not highly trained, the old farmers. So all they need to do is that they know how to push the buttons, right? From the cell phone, on, off, and then those are the very, very basic things. We do not want a complicated system for the old farmers. But for the young farmers, for let's say the second generations, they are more comfortable with technology things. Then maybe we can let them go to change the setting. For example, they can change sampling rate, how high you want the fan to turn on, how low you want the temperature goes, and the system will send alert to the user. So I think the technology come into two level. It depends on how trainful the user is.
Oh, okay.
For the development part, I think for the programming and also the wiring, it is not a good idea for the beekeepers to get involved, because they may mess up the whole things. Yes.
Oh, yes, I see.
And teaching them is a long time. So don't waste time to train them. Yeah.
Okay. Pak Andri, can I ask one more?
Okay. One question. Okay.
Prof.
It's
Leong,
okay.
one question. Okay.
Thank you.
And the Prof. Leong use ThinkSpeak to connect the device. And if we use in the rural area,
yes,
that is non-network, what we can do to do?
Yes, I think this is the one of the big problem many people challenge when you need to use the cloud. Then you need Wi-Fi, and especially when you have a big farm, and especially when I talk about the professional beekeepers, they have 200, 300 bee box. So most of the times they would place their box in the mountainous area. So there is no Wi-Fi connections. So that is maybe one of the reasons why I did not plan to go go with them to do my testing. Instead, I would use the farming. I think you ask a very, very good questions. I still looking for methods to solve this problem.
Okay.
Especially when the power is another big problem. Yeah, the power supply in the mountainous area or in the forest. Good questions, but so far at this moment we are still looking for alternative to solve this. Yes.
Okay. Thank you, Prof.
Thank you.
Okay.
Very good questions.
Okay, thank you, Mr. Guyup Mardian, for the question. Yeah, actually, the question is regarding the challenge in the also in tropical country. So we don't have enough signal for sending the data by cloud system. That's also one of our topics in Indonesia is how can we make a system that can works in the blank spot area. Blank spot area, I mean, they don't have a signal, and the one technology is LoRa technology. Maybe next time we can collaborate using LoRa technology.
Yes, I think for the rural area, one way is that maybe they will do the recording, the data recording, on-site recording, and maybe the farmers every 1 or 2 years, 1 or 2 days, they will go to the spot and then they download the data, and then from there they may be able to visualize, see the trend, but they won't be able to do the real-time tracing of the information. Yeah.
Okay, any other question from student? I would like to invite student to ask to Prof. Leong here. Any other question? Okay, while waiting for the question, I saw that your research is mostly for the developing of the system at first for hardware and software, and also the simulation using CFD.
Yes.
So is there any, course, given in the study program as base for the student making that research, or you have to train by yourself? Okay, study this one, or using DIY kit. So
yes, actually, because I'm from the vehicle engineering, so in my department, my students, they are asked to learn visual modeling, like how to use computer software to build a model, a virtual model. And they learn this skill in their second year. And then they learn like fluid mechanics, heat transfer also in second year. And the students are also required to study, to learn electronics, programming and wiring in second year. So with this, they have a very general understandings of the technology or what they need to use for the project. So in more advanced classes, for example, in the third year or fourth year, they will learn computer simulations. For example, they can use NC systems, Fluent, and this kind of software where they can build the model. And of course, building the model is easy, but making the numbers are difficult.
Yes.
So in my lab, throughout the guidance, so I set a schedule for my students, and then we talk about how to collect the data. And sometimes we went to the beekeepers. They don't have the data. They just say, oh, okay, we normally collect the honey in February and March. And then somehow we found that the bees numbers are decreasing in which month. So that's about it. So we still have to spend a lot of efforts trying to collect useful information for our applications. Yeah. So I think learning the basic skill are from the department courses. Yeah, like Arduino, we have a lab where we teach simple introductions to how our students can use the board and put sensors together and do simple recording and measurement. And from there, we teach them how to do proper interpretations of the data and how to make graph and tables and stuff like that.
Yeah, I hope that our student also hear this one information, like the motivation for study about the programming, about the modeling, also the mathematics is one of the important fundamental for the research.
Yes.
Because in our students, sometimes they feel like afraid about the programming one.
Yes. Yes.
Yeah.
Yes.
That's one of the, maybe if they show the reality that can be solved by programming, maybe this one on the motivation, I think.
Yes. Yes. But in my past experience, I sometimes look at the student behavior. For example, some students, they are very good in mathematics. So for this kind of students, normally I would try to encourage them to do mathematical modeling. Yeah. And some students, they are very careless. They're very, very careless. So for this kind of students, most of the times I would ask them to do experiment. Because when you do CFD, you are not careful enough. You would spend a lot of time building the models, and the model cannot be used. And sometimes when they do have the simulation result, and the result doesn't make sense, it is wrong. It just, oh, how can this be?
Yeah.
So and then because they are careless, they do many, many small errors. So for those who are careless, if they do experiment, I will go to the lab and see, okay, why not you run the experiment and I will see what is going on. Then most of the times I will able to say, oh, okay, you see, this is wrong, this is wrong, this is wrong. So right away we can give them good suggestions to improve. Yeah. So those are sometimes, if possible, I would look at the students' nature and then assign the approach for them.
Yeah, if we use like a simulation, sometimes is any number you input, maybe the result would come out.
Yes, garbage in, garbage out.
Garbage in, garbage out.
Yes.
Yeah, that's the I mean, the behavior of the simulation.
Yes, yes.
Okay, any other question from participants, student, or maybe lecturers, or any other? Okay, if you have any question. No, no more question.
I put on the chat.
Oh, okay.
How long it took for the project to complete from beginning to get the good results?
Oh, okay.
I would say less than 3 years, but definitely more than 2 years. Yeah. In the first phase, we faced a lot of problem trying to collect the right numbers. For example, how the B numbers varies within a year. So that took us a long time. And also, when we do the simulations, we have to find, like, for example, the B generation, the heat generation from the B. And that equations took us a long time to find. Even we went to the College of Agriculture and we asked the professor, and they don't know. They said, well, we have never thought of measuring these things before. So we have to read a lot of the information. We surf the net, and then we found many versions of equations. And then we try to put the equations into our simulations, and boom, we get the results. But the temperature is like 50 degrees Celsius in a B box. So obviously something is wrong. Because in a B box, according to the literature, if the B box, the temperature is higher than 38 degrees Celsius, most likely the bees would not take efforts to cool down the beehive. They will flee, they just fly away. So if you use the wrong model and then we do the simulations and the temperature is 50 degrees Celsius, something must be wrong. So and then we came back to the literature, and then we looked for the right equations. And we were very lucky. We found one equation that makes sense. So what happens to these equations? So I think because some research, when they say, let's say Mr. So-and-so, Professor so-and-so, they say, based on our experiment, we found that a bee would generate, let's say, 5 milliwatts. So yes, one bee generates 5 milliwatts, but 1,000 bees doesn't mean they generate 5,000 times. Because when bees, they come together, the heat generation rate reduces. So maybe the informations we get over predict the heat generations, but from the report, we just couldn't tell. So that's why we spend many times trying to refine our simulation model. And for the Arduino things, that is not too difficult. We spent about 1.5 years making everything work, including the Wi-Fi, the app. So that is okay. And for the weighting projects are about 1 year. The weighting project is about 1 year because in the beginning, the data doesn't make sense. The quality of the data was very terrible. So we sit together and we try to play with many things, test, and eventually we thought spring. We get this idea from car because car has suspension, and we thought, wow, yes, why not we use the car concepts to solve this problem? And we were lucky that we were able to improve the data. Yes.
Okay, for continuing the question, if we develop the appropriate technology and it can solve the problem, and our product actually is prototype, right? Like
yes.
a prototype.
Yes.
And sometimes the industrial sector, they interested to adopt the technology. How to deal with this situation? They want to make a reproduce or mass production. How to deal with that situation?
I'm not sure how things happens in Indonesia, but in Taiwan, there are two kinds of company. one company, the good ones, they want to buy your ideas and then they redo the whole things. For example, our prototype may not be very waterproof. The span of life is shorter. So maybe the good companies, they will say, oh, okay, so these are, for example, my mathematical model, where to put the sensors, though these kind of ideas or these kind of equations can be applied in their model. So they will buy these kind of things and then they build their own system. So I think this kind of company is better because they know what they're doing. But somehow the small company are very dangerous. They will approach you and then they will say, I am going to duplicate your systems. And then I sell it to the public. So this is a very dangerous thing because we in the university, we do not have so much time to test our model. Yeah, and because in the big company, they know what is good for what functions. So if they develop their own systems, the system has a better quality. But they use the one that we use, I'm worried. Yeah. So that is what I think of good and bad companies. So big or small companies. Yeah.
Yeah. So we have to protect our rights, like for the
yeah.
Right,
actually, in the university, if we have good ideas, we may approach the Office of Research and Development and ask them how they can help with like patenting your idea and how to how to negotiate the proper technology transfer. So most likely they can give us a very good suggestions on that part. Yeah, because we have very limited experience how to talk about money with the businessman.
Yeah, the same things here.
Yes.
Actually, if we go for the company come from the come to our lab and asking about, can we make the system like this? And we still thinking about, oh, maybe they need money. So
yes, yes.
Okay, other question maybe from audience?
Professor, I'm sorry.
Okay, Dr. Chandra again. Okay,
yes,
please.
Maybe this is out of the topic. It's about the collaboration. So is it possible if maybe because today's participant is not just from UGM but also from some
other university.
Yes, like Lampung University, Sriwijaya University, and others. So is it possible if maybe there are some faculty member from Indonesia to do postdoctoral research in your laboratory?
Yes. I think you are always welcome. I think we have to do things together. Yes. Of course, they are all welcome. And if I'm not knowledgeable or I'm not in this area, I can be the middleman to make connections and see who in the university are more suitable to form the team. So that is okay. Yes, I would love to do that.
Thank you. I think it's it's become nice information for us and also maybe for our student
participant. Yes.
Yeah.
Also for participant is also one of the you can get scholarship maybe or support to study in Taiwan. So
yes.
Okay, if there is no other question, I make a notes for your interesting quotes here.
Thank you.
As engineer who want to apply our knowledge, we have to go outside and see directly in the actual real life experience instead of stay in our lab. And we have to solve the problem using our innovation and also our engineering skills. And one also the important thing is the communication. Is the key of the success of the transport, the technology to the farmer. Okay, this is the last but not least. If you have any closing remarks for our students, please, Prof.
Yes.
Leong.
Once again, thanks for inviting me. It is my great honor to have this chance to briefly introduce. I think I would not want to say this is the technology, but I would like to say this is the tools. As an engineer, what kind of tools we use to solve the problem. And sometimes because we have different background, we are unaware of the tools other party are using. So in engineering field, especially mechanical engineers, we use mathematics, we use computer, we use lab equipment to achieve our goal. So by knowing what we can do and by knowing what you need, I think different parties or different teams can form and to have a more meaningful research. So I think this is my purpose, to share with you the tools that we can solve problems together. And for the students, always remember, communication is very important. Before you tackle the problem, you communicate and to make sure you understand the problem. And then you communicate again when you try to come up with the solutions. And then once you think you get a very good solutions, don't think, don't imagine, go talk again and ask the user, is this what you want? Is this what you like? If yes, then you move on. So I think again, communication is very, very important. Yeah. Mm-hmm. So with this, I think I'm very honored to be here, and thanks Dr. Andri for hosting me, and thank you Dr. Chandra and other professors who give me patience to understand the tools that I use to do my simple research. Thank you.
Okay, thank you very much, Professor Leong, for the lectures. And actually, we are also happy to have you here in today's seminar. And we also get some insight regarding the technology, appropriate technology, and also approach to make sure that our technology transferred well to the farmer. On behalf of the Department of Agricultural and Biosistem Engineering, Faculty of Agricultural Technology, Universitas Gadjah Mada, I would like to say thank you. I also give you the virtual certificate. Maybe this is yeah.
Wow, thank you.
Virtual certificate for.
Thank you.
Yeah. And we hope that in the future, we can meet again, maybe in Taiwan, or you come to UGM.
Yes, I would love to. Thank you.
Next year in EcoSet.
Next year. Yes, July.
Yeah, in Bangga, in Bangga.
Bangga.
Yes. Okay, I believe that your lecture material and explanation will give us new understanding about the role of appropriate technology for supporting agricultural industrial development. Okay, for the last, maybe I would like to invite all participants to turn on your camera. We will make a photos together. Yeah. Please turn on your camera, and the one who want to have a picture together with Prof. Leong.
Oh, thank you.
Okay, committee, please count if you take a pictures. Okay, maybe slide one. I would like to count. Okay, prepare your hair and also your clothes. Make sure that your hair is okay. 1, 2, 3. First slide. Okay, second slide. 1, 2, 3. And the last slide. 1, 2, 3. Okay. Okay, once again, thank you very much, Prof. Leong, for your time and your share for the experience regarding this material. And see you next time.
Okay.
And thank you very much.
Thank you, everyone, and thank you all the professors and students. Thank you.
Okay, now I will return to the MC. Thank you.
Thank you to Mr. Andri, who has led the discussion this afternoon. Once again, thank you to Professor Dr. Jik-Chang Leong, who have presence today listens. Thank you to all participants who have attended this quiz lecture until the end of this event. It is remind again for all participants to fill the present that has been shared in the chat room. because we only distribute the certificate to participants who have been filled out the attendance list. And for the next event, it will be the quiz lecture on Friday, 12 November 2020. For further information can be accessed on our social media. On the behalf of the Committee on Duty, I apologize if there are many wrong words and action. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.